Hi students, welcome to Alpha C learning program mathematics class. In previous session students, we have discussed tangent properties etc. Some examples also we have discussed. Now let us consider here chord of contact and after that normal. Okay. So what about here chord of contact? In circles already you know about chord of contact. And the chord of contact is nothing but here, suppose you consider any curve. Let us take here a parabola. Okay, let us take here a parabola. Y square is 4ax. Then from a point if we are taking tangents to this curve, and earlier we have observed from a point outside any curve we can draw two distinct tangents here. Like that we are taking here two tangents to the curve, and therefore these are the two tangents. Okay, and now these two tangents, suppose these are touching the curve at exactly a comma b. So these two tangents, they are touching the curve at a and b, and if this is our p of x1 comma y1, then if you join these points of contact, okay, if we join these points of contact, then this line joining is said to be nothing but what here? Chord of contact. Okay, so chord of contact of what? Actually the sentence formation is nothing but here chord of contact of the point p of x1 comma y1 with respect to the curve s equal to 0. Okay, so chord of contact of the point x1 y1 with respect to the curve s equal to 0. That is the meaning. Now how you can obtain this equation of chord of contact? But what are necessary conditions? Whenever chord of contact you are using the word implies, the point has to be from outside, because then only we can draw here two tangents. Whenever two tangents there, then only you can check here the points of contact we can join. Okay, therefore what is chord of contact? It is the line joining points of contact. Line joining points of contact of two tangents which are drawn from a point x1 comma y1 to a curve s equal to 0 is nothing but what here? Chord of contact. Okay, so now what about here the equation? How to obtain equation of chord of contact? Now you know here, suppose this point I am taking here as at1 square comma 2at1, and this one as here at2 square comma 2at2, or you can use here any concept here. This you take x2 y2 and x3 y3. Okay, any of the values. Suppose let me take, if at all you have confusion, x2 y2 I am taking, and this one as let us take x3 y3. Okay, then what about here equation of tangent drawn at a? Okay, tangent at a value, that means this equation is nothing but here y1 place you are having here y2 minus 2a into x plus x2 equal to 0. Okay, this is equation drawn at a. And similarly drawn at b, if I write, this is nothing but y3 minus 2a into x plus x3 equal to 0. Implies here the a and b both are here on a line. Understand? Implies a comma b, they lie on, actually on which kind of line? Some value. Suppose if I write some y into alpha minus 2a into this is x plus some beta, or here y beta, this is x plus alpha equal to 0. That implies this equation is just like whatever s1 equal to 0. Therefore we simplify, the equation is nothing but here s1 is 0. Okay, and exactly here that x1 y1 we are taking, the reason is what here, why we are taking exactly at x1 y1? Because here tangent drawn at a, it is passing through which point? It is passing through x1 comma y1. So if for clarity I am writing here, that is the tangent at a is passing through which one here? At a is passing through x1 comma y1. Okay, as it is passing through x1 y1, therefore we write this value as here y1 y2 minus 2a into x1 plus x2 equal to 0. Similarly this tangent at b also same condition, then we write y1 y3 minus 2a into this is x1 plus x3 equal to 0. Okay, now what we can say clearly, that implies x2 comma y2 x3 comma y3. Okay, x2 comma y2 comma x3 comma y3, both the points they are on which kind of line? Actually it is y1 minus 2a into x plus x1 is equal to 0. Okay, therefore here students we can observe here the equation of chord of contact of the point is nothing but which one? S1 is 0, because these 2 points are here exactly the end points of this chord and which are on this line, they are satisfying in this way, hence this is our equation of chord of contact. Okay, now once you got this, it is nothing but S1 equal to 0. Therefore you can generalize, that means for any curve S equal to 0, circle, parabola, ellipse, hyperbola, any curve S equal to 0 if you consider, and from a point x1 y1 which is outside the curve, 2 tangents can be drawn, and if you join those 2 points of contact here, it is nothing but chord of contact, and whose equation is nothing but here S1 is equal to 0. Okay, now students you understand here one thing, same S1 is 0, you are having formula for even tangent also. Okay, tangent also, there also you have taken at x1 y1. That means if the point is exactly on the curve, then we call it as actually tangent at the point x1 y1. That equation is nothing but S1 is 0 to any curve S equal to 0. Okay, therefore whatever tangent formula are there, here also you can apply, but here positions are different, isn't it? The point position is outside the curve, etc. Positions are different. So now here you know what about here equation of chord of contact. Okay, and next one, our interest is here, what about here points of intersection. Okay, this point of intersection of tangents. Simply students you can make use of here, earlier whenever Lx plus My plus N equal to 0. Okay, Lx plus My plus N equal to 0. Suppose this is our chord of contact. Okay, this is our chord of contact, Lx plus My plus N is 0. Okay, now they will ask about here what is, that means this equation is given. Now they will ask about what about here the point of intersection of tangents. Okay, point of intersection of tangents drawn at the ends of chord of contact Lx plus My plus N is 0 to the parabola. Suppose we are taking y square equal to 4ax. Okay, so what about that value? So here you can make use of simply the previous formula, easily you can remember, that is whatever tangency, that is point of contact formula, same thing you can use, because there also you are taking S1 is 0 as tangent. How you got this is our actual tangent, whenever actual chord of contact, whenever x1 y1 is the point outside. So if you take x1 y1 as point of intersection of the 2 tangent students, then this is our equation of chord of contact. Okay, so with respect to the formula, the actual chord of contact is this one. So this is actually equation 1, which is equation of chord of contact of which one here, this is point x1 y1, that is with respect to the given parabola. So equation of chord of contact, this one we are taking when x1 y1 is point of intersection of tangents. But actually what is our chord of contact here? Lx plus My plus N is 0. Okay, this is actual given chord of contact. And now here if you compare, that means both the equations they are representing here same line. Okay, both the equations they are representing same line, implies corresponding coefficients are in same ratio. Therefore if I write here, this is minus 2a divided by L, x coefficient, and next y coefficient if I write, it is y1 divided by m, and this side the constant value, that is nothing but here minus 2a x1 divided by how much it is n, right? And now if I take equate these two values here, 2a get cancelled, thereby x1 is nothing but how much here, n by L. And what about y1 here? Y1 is nothing but here minus 2am divided by L. Okay, therefore this point is nothing but how much here, n by L comma minus 2am by L, point of intersection of tangents. In the same one actually you have used actually here the point of contact when tangent is Lx plus My plus N is 0 and this curve is y square equal to 4ax, then also we have taken it as actually point of contact. Therefore if they use the word as chord of contact, this is the formula for point of intersection of the two tangents, and if they used it as a tangent, then point of contact also you can use the same kind of formula. Okay, now so students, now you got here point of intersection of tangents drawn at the ends of chord given. Okay, so this formula remember very well, because here by using this formula some locus problems are there, easily we can solve those locus problems. Okay, and next one is, what about the next one? Length of chord of contact. Okay, length of chord of contact of a point P of x1 y1 to the parabola. What about the value? So earlier we have observed, students, actually chords you are observing three kinds of chords. Okay, so here suppose the parabola has taken, earlier we have taken the chord value, and here when these 2 points are given, x1 y1 x2 y2 given, that means when the 2 points are on the curve, then this is known as chord joining 2 points. Okay, and next one, when the middle point is given, when the middle point is given, then we have observed here this is also a chord, but what is the data here? Data is chord with middle point, here chord with end points, thereby we observed this kind of standard formula conceptual, whereas in numerical directly you can find line joining 2 points. Okay, now whenever middle point is given, then you have used the formula S1 equal to S11, and now here the point is exactly outside the curve. Okay, now also you are taking chord equation, that is what actually S1 is 0, but what is the relative position of the point you are using? One suffix means point x1 y1, it is falling exactly here outside the curve. Okay, so this is our x1 y1. Now basing on this, actually all are representing chords only. Okay, all are representing chords only, but the data is different. Here data is middle point given to the curve SC0, this is the formula. Here data is end points are given, then this is the formula, and here the data is point is outside, therefore this is our formula. But each and everything is representing what here? Same chord equation only. Okay, so point outside, point inside, point is on, all three categories we got here equations of chord. Now earlier also you found here length of chord actually. Okay, this formula already we have derived. What is that formula you got there? It is under root of, it is minus S11 and into y1 square plus 4a square divided by how much you got this value? A. Of course a here you are taking positive, so no need to write mod a. Now this value you got when the point is inside, right? When the point is inside, therefore minus S11 it will become again positive itself, as S11 value is here negative. So there you got this concept by using the standard notation we derived, that is chord length using T1 and T2. Okay, from that we have substituted middle point, and thereby you can observe this one. Now here also students, if you consider this length of the chord, then what about the formula? Exactly same formula only, but instead of this minus S11, now you got here how much? Root of S11 into same value y1 square plus 4a square divided by how much? A. Both are actually length of chord only they are representing. Here point is inside, so minus S11. Here point is outside, therefore it is S11. Okay. Now how we got? Just it is only 2-3 steps only. You can understand very easily the length of chord of contact. Okay. How to obtain this value? So you can remember it as formula, or we can do like this for standard form. Now you are deriving. So if I take this is the chord value, that means chord of contact x1 comma y1 drawn from x1 y1. Okay, so this is the chord drawn from this one. So this x1 y1 students, actually I am taking here a t1 square comma 2a t1, and this is a t2 square comma 2a t2, right? And in previous sessions we have observed about point of intersection of tangents. Okay, then if you use that formula here, because you are taking at the ends of T1 and T2, therefore this value is nothing but a T1 T2 comma how much it is? A into T1 plus T2, right? That implies what is your x1 value? X1 is a T1 T2, okay, or x1 by a equal to how much here? T1 T2. In the same way y1 divided by a equal to what is that value here? T1 plus T2, right? And now what about actually length of the chord joining 2 points in terms of parametric model? That is nothing but actually it is A into, okay, mod of T1 minus T2 and into under root of T1 plus T2 whole square plus 4. So this is our formula, students, length of chord joining 2 points T1 and T2. Now mod T1 minus T2, you can make use of here relation. What is mod T1 minus T2 whole square? First I am writing. Okay, this you know clearly, T1 plus T2 whole square minus how much it is? 4T1 T2. Okay, then if I write this value, it is y1 square divided by a square minus 4 into T1 T2 means x1 divided by a. That implies it is y1 square minus 4a x1 divided by how much it is? A square. That means what is that value? If you take the square root, then it is nothing but root s11 divided by mod a. Okay, therefore you got this value is how much here? It is root of s11 divided by a positive, so directly we are writing. And into what about here? T1 plus T2, that is nothing but our y1 by a. Therefore this is y1 square by a square plus 4, right? And now here these two values get cancelled and it is root of s11, and here if you take LCM, y1 square plus 4a square divided by a square means what is the value? A. So in this way, students, you got here length of the chord, and what is this x1 y1? Actually it is a point which is outside the curve. Okay, earlier while doing the middle point concept there, that x1 y1 whatever you have substituted, that is the midpoint of chord, whereas here this point is outside, which is nothing but point of intersection of the two tangents. Okay, so this is our formula for length of chord of contact drawn from the point x1 comma y1 to the parabola y square equal to 4ax, right? And next one, students, they may ask here about area of triangle. Okay, area of triangle formed by chord of contact and the two tangents. Same concept you have done even in the previous chapter, circles also. Okay, so area of triangle using chord of contact and the two tangents. So what about that kind of area? Now if this is the parabola, and now here two tangents we are taking, and these are at 81 square comma 281, and this one is at 82 square comma 282. Anywhere you can consider. Okay, now what is the standard parabola you are taking? Y square equal to 4ax. Okay, so this is the standard form we are taking, and now this point is actually what? This is x1 comma y1, or if you take in parametric form, it is a t1 t2 comma a into t1 plus t2. So now what about here? Our interest is what is the area of triangle formed by the two tangents and exactly the point, this one, chord of contact. So we require this kind of area. Okay, so this is our chord of contact. And what is our chord of contact equation? Actually it is S1 is 0. So you can use many methods, students. Actually now I am using one of the methods. The method is nothing but simply the basic formula, half base into height, because just now we've obtained the length of the chord of contact. Okay, so now this is our base. Suppose you take these are A and B and this is the P value, then AB is nothing but length of chord of contact, just now we have derived, and this one, other one, you have to take perpendicular distance from P onto this chord of contact line. Okay, so this one is the other. Therefore what is our formula now? It is delta, area is nothing but half AB and into how much it is? PM. Okay, AB just now we found what is that value? It is nothing but half, it is under root of S11 and into y1 square plus 4a square divided by what is the value you got? A, right? So in this way you got here length of chord of contact. And now our interest is here PM. PM means what is this equation? Actually S1 is 0. S1 is 0 means what is that? Y by 1 minus 2a into x plus x1 is equal to 0. That implies minus 2ax plus y by 1 and minus 2ax1 is equal to 0. Okay, now PM length means how much you can obtain here? perpendicular distance from x1 y1 onto this line. Thereby it is minus 2ax1 and plus it is y1 square, and again this is how much students you got? Minus 2ax1 divided by denominator is under root of 4a square plus y1 square, right? And now this is actually mod value. Therefore it is y1 square minus 4ax1 implies again it is what our notation s11 divided by this is y1 square plus 4a square under root. Therefore that value now let us substitute here. Then what will happen here? Pm we are substituting. Now if I substitute Pm value here, it is nothing but one more s11 you got here, and divided by denominator is under root of y1 square plus 4a square. So here also that value and here also you can cancel. So finally what is our value? s11 to the power of 3 by 2 divided by 2a. So students, this is our formula for area of triangle formed by chord of contact with its tangents to a parabola y square equal to 4ax. Okay. Now students, if they ask a problem like this, that is the angle subtended by chord of contact of a parabola, that means chord of contact of a point. And where is that point here? It is lying on a line x plus 4a is 0 and at the vertex of parabola. Then what about the angle? Okay, so what is the curve given here? Y square is 4ax. So this is our y square equal to 4ax curve, right? So y square equal to 4ax curve given, and now they are asking about here if chord of contact is drawn at from a point. What is the point? Where the line x plus 4a is 0. Suppose this is the line x plus 4a equal to 0. Okay. Now x plus 4a is 0 from a point on this line. From a point on this line, if it is taken like this, the chord, this is tangents first we have to consider, and then correspondingly we say this is our chord of contact. And now what they are asking here, this chord of contact, whatever s1 is 0, okay, this chord of contact, if it is subtending, that means some angle at the vertex of parabola. Now the question is, what is this angle? Okay, what is this angle? And here vertex, you know, it is 0 comma 0. Now students, you know here clearly on the line x plus 4a is 0 means clearly the abscissa is nothing but what here? Minus 4a, and ordinate let us take as usual y1. Okay. Now what is the question actually? The chord of contact, that means this chord of contact of the point minus 4a comma y1 subtends at the vertex what kind of angle? Okay. Now whenever any line is subtending some angle at origin, then simply we use the procedure of nothing but here the homogenization concept. Okay. Now s1 is 0, then what about the equation here? This implies y1 minus 2a into x plus x1. Now what is our x1 students here? It is nothing but minus 4a. Okay. So this is nothing but minus 4a is equal to 0. So this is our equation of chord of contact. Now we want to do here homogenization, that implies y1 minus 2ax is equal to 8a square. Then divide by that value. So y1 minus 2ax by 8a square is equal to 1. Now where we substitute this one for homogenization process, we write here y square minus 4ax into 1, okay, is 0. Now we substitute this value 1 here, that is y square minus 4ax into y1 minus 2ax divided by 8a square is 0. Now what about here? First of all observe, this equation is homogeneous, that means like this you got combined equation of, suppose you take BC, it is a combined equation of AB and AC, and therefore you can obtain here homogeneous equation of the form ax square plus 2hxy plus by square equal to 0. Therefore here first let us observe, this is our y square coefficient. So y square coefficient usually we represent by b, or let us take with capital B, this is 1. And let's observe about x square coefficient. This is how much you got? 8a square divided by 8a square. The coefficient is here how much you got? x square coefficient we are taking. Okay, therefore you got here 4ax, and this value if I write, it is minus into minus plus. Okay, then we can obtain here exactly the angle subtended by the point. So here you got, this is how much actually, minus value. So I am writing here minus and thereby here minus. Therefore students, you got here a is how much actually, minus 1. So you got students now coefficient of x square plus coefficient of y square is 0. Once you got that condition, then immediately what is angle here? The angle is here exactly 90 degrees. Okay, therefore angle subtended by chord of contact of a point which lies on the line x plus 4a is 0, subtends how much here? It is 90 degrees at the vertex of parabola. So these model actually we depend on what actually, homogenization provided the point, it is nothing but origin. Okay, so vertex is origin, therefore you know about this one. And here minus 2ax, minus into minus, plus 8a square, if it goes that side it is minus 8a square, and thereby we divided and substitute this value 1 in the given equation of the curve for homogenization. Then you got here coefficient of y square is 1, coefficient of x square is plus into minus, it is minus 1, hence a plus b value is 0. Therefore the angle is how much here? 90 degrees, right? Now students, let us observe about equation of normal. So far we have discussed here about different chords, and next one tangent. Let us observe now what about equation of normal to a parabola drawn at a point t. Actually in first year while discussing about tangents and normals concept, all of you know very well what about a normal. Normal means to any curve, if you take a tangent, then the perpendicular, many perpendiculars are there to any line, then the normal, that means perpendicular which is drawn exactly at the point of contact. So this is known as actually normal of this curve. Okay, and now here this normal means which is drawn exactly at the point of contact of tangent and the curve, and now here tangent and normal, these two are perpendicular at the point of contact. Okay, that means here normal comma tangent comma curve, both all these three coincide at the point of contact. Then how to find here equation of normal to a parabola? Y square is 4ax. So let us consider first of all the standard form. Okay, now we know clearly what about equation of the tangent. Tangent equation at t is yt equal to x plus at square drawn at the point at square comma 2at. Then we call in general at which value here? T. Then what is the slope of this tangent? Slope is nothing but here 1 divided by t. Okay, slope is 1 by t, and this is for which parabola? Y square equal to 4ax. Okay, to the parabola y square is 4ax. So this one. And now we want to get here normal equation. As slope of tangent at t is 1 by t, therefore you are finding normal at the same point of contact, implies slope of normal is how much now? Slope of normal is nothing but minus t. Okay, so this one is here tangent slope you got, and this one is here slope of normal is minus t, and same point of contact. Therefore we can say equation of normal is our usual formula, that is you know about here slope and you know the point of contact. Equation of normal, again preposition at. Okay, at t to the parabola y square equal to 4ax is y minus y1, that is 2at equal to what is the slope you got here? Minus t. Okay, into x minus at square. Then if you simplify, it is y minus 2at equal to minus tx, means it is minus tx plus at cube. Okay, that implies if you take x value this side, y plus xt is nothing but 2at plus at cube. So students, this is equation of normal drawn at the point t to a parabola y square equal to 4ax. Okay, again we need to remember, because in parabola normal concept is very important. Now let us have a glance students here regarding all these values. That means different parabolas you are having. Y square is 4ax and this is the parametric coordinates for this curve. And now this is chord joining 2 points we wrote, you know already, and this one is equation of tangent exactly at the point T. Then what about equation of normal? Just now we have observed it is nothing but y plus xt is how much here? 2at plus at cube. Okay. Then what about for y square is minus 4ax? For y square is minus 4ax, here change is in x coordinate. Okay. Replace x by minus x. That means change in x coordinate. And here also replace x by minus x. Okay. And here also replace x by minus x. In the same way here also just replace x by minus x. So this is here parabola y square is minus 4ax. This is the normal equation. And next one, if you take x square is 4ay. Many times we have discussed that these two parabolas are here images of one another with respect to the line y equal to x. Therefore just interchange x and y. Here coordinates we interchanged, and here also just interchange x and y. Okay, interchange x and y, and in tangent equation also just interchange x and y. Similarly in normal also just interchange x and y. Okay, therefore for x square is 4ay, the equation of normal drawn at the point T is nothing but interchange here xy, that is x plus yt equal to 2at plus at cube, right? And now for x square is minus 4ay, then what is the change here? Just replace y by how much here? Minus y. Everywhere replace y by minus y. Here also like this. Okay, coordinate wise. So students, just you observe the difference, how you got all values parabola equation. So that means one set of formula if you are able to remember, simply you can write for other three. Not only these, axis is along x axis or along y axis. Suppose axis is here parallel to x axis. Replace y as y minus beta, x as x minus alpha. Then here just add alpha, add beta. Okay. Now y means you write y minus beta, x means write x minus alpha, and here y minus beta, x minus alpha. Similarly here also y replaced by y minus beta, x replaced by x minus alpha. So students, in this way easily you can come across with here this kind of formulae. So now we found at present the equation of normal at a point T to the standard form is nothing but this one. Okay.